Hi everyone. So good evening, right? So in this session, I'm gonna talk about linear algebra only, and I will be discussing from the very basics. Again, I will talk about vectors, okay, and we will talk about dot product of vectors as well. And today we will understand the what is the meaning of norms, right? Because nowadays in the gate examination the concept of norms are being asked frequently. So we will talk about what is the meaning of norms, okay, or the length of a vector, and we will also discuss about orthogonality, okay, and we will see how in fact we are going to prove also the condition for orthogonality, right, using matrices. So the problem starts, the discussion will start from the very basic only. The you can say the system of linear equation, the central problem, right? The central problem of linear algebra is what? Already we know that, right? The okay, central problem of linear algebra, LA, is to solve system of linear equation, right? Suppose we have been given a system of linear equation of this kind, like a11x1 plus a12x2 plus and so on, okay, plus a1 and xn, you can say, and equal to b1, right? So we are just taking the non-homogeneous system of linear equation, right? Central problem of linear algebra is to solve system of linear equation, right? So we are going to get this kind of equations, and we'll get the matrix as well as the vectors, right? So we call them as a column vector or a row vector, right? That you have to keep in mind. So I'm recording this session so you guys can watch this session later as well. Okay, so then a21 x1 plus a22 x2 and so on and so forth plus a2n xn here, right? And this is b2, okay, and so on and so forth. You will be having a m1, right, x1 plus am2 x2 plus okay, amn, right, xn, which is equal to bm. So these are the system of linear equation, and we can write this in compact form, okay, representation, that is ax equal to b. So what we are doing here is we are multiplying matrices, coefficient matrix with the vector, and we are getting the same vector. So these are the column vector, okay, we call them as a column vector. In fact, I have shown you the geometrical interpretation of the vectors as well, so you might have seen, right? So this is also again one column vector, okay. So this is one of the, you can say, transformation, right? If you are taking a matrix, okay, augment kind of square matrix or any kind of matrix, and you are multiplying with the column vector, right? So you are getting the column vector itself, right? So what is the meaning of vector? Everybody knows that vector means it has it can have the magnitude, okay, and it can have the direction, and direction is represented using an arrow, and magnitude is represented using the length of the vector, okay. If you are representing length of the vector, that gives you the magnitude, right? So these are the very basic thing which everybody knows, okay. So I hope this makes sense to everyone. Let me check the my voice and everything, otherwise we are running the session, and yeah. So I'm just going to go ahead. So keep in mind, while solving the system of linear equation, okay, we will be most of the time talking about column vectors, linearly independent vectors, linearly dependent vectors. So today we are going to understand what is vector and how to take the dot product of vector in terms of matrices, right? Okay. So these sometimes row and column vectors columns are known as row vector and column vector. That you have to keep in mind. Understood? So my column vector will be what? My column vector will be equal to, this is a vector x, okay, we call it vector x, and this is a column vector. So any vector will be having its component x1, x2 and so on, xn, right? If somebody is going to ask you what is the size of this matrix, so this has a n cross 1 matrix, because there is one column and there is n number of rows, right? So we call this as a n cross 1 matrix, right? So it is a column vector basically, right? And your b vector will be what? B vector will be the collection of what? This is, you can say, the constant one, b1, b2, and they are the components, right? bn, right? So bm, you can say, yeah. So these are the column vector. This is again m cross n. Right? So you can see here the this is column vector, okay, and these are the components x1, x2, xn. Understood? I have shown also how to represent vectors in the plane, okay, in the xy plane or in 3-dimensional, okay. So that everybody knows. Understood? So any vector can have the magnitude as well as the direction. So there is a there is a very important terminology in linear algebra we are going to use is the norms. What is the meaning of norms of a vector? Norms of a vector is nothing but, okay, that you have to keep in mind, okay, why we are using norms. That is a very important concept one should know, right? So first of all, you should know the meaning of norms, okay, the objective, okay, what is the objective of norms, right? So norms are a way of measuring length of a vector, okay, that this line you have to keep in mind, okay. Norms are, right, you can say they are ways of measuring, okay, measuring the length of a vector, okay. This word is very, very important, length of, okay. If you want to measure the length of a vector, so you have to talk the concept about concept of norms, right? Okay, or okay, so what does this length describe basically, okay, that you should know why we are measuring the length of a vector, right? So that you have to keep in mind. So length of the vector basically is going to describe, remember this, which describes, okay, which describes, okay, how big or small the vector is, okay, how big or you can say small the vector is, okay. That this is very important concept. Or suppose we have been given two vectors. This is the first definition of norms, okay. Keep in mind, norms of a vector means what? They are the ways of measuring the length of a vector, right? Norms is what? One of the ways, you can say. If you want to measure the length of the vector, okay, why we are measuring the length of the vector? Because we want to know that how big the vector is, how small the vector is, right? Or there is a very important definition, and this definition is practical definition I'm telling you, right? Practically how norms are defined, right? So suppose we have been given a two vectors, right? Remember, suppose we have been given two vectors. Suppose two vectors are given, okay. Suppose two vectors are given. I'm talking about two vectors are given means what? Suppose we have been given one picture. This is your old picture, you can say Aadhaar card one. You can say this is Aadhaar card one picture, right? Aadhaar card. Okay, Aadhaar card one picture, right? Everybody knows that what kind of pictures are there in Aadhaar card, right? So it has some pixel components, right? So we are going to collect that, okay. You can say V1 is there, and these are the pixels V1, V2, V3, and Vn, right? You can say. And the present picture you can take. There are two pictures, and we are going to compare these two pictures, okay. We are going to compare these two pictures. So again, this is one picture, right? You can say present one, present picture, right? And this is old one, right? You can say Aadhaar card one, okay. So we are going to collect again in terms of vector, right? Because the pixels are being kept in terms of component, you can say. So this is again V2, okay. So V2 is having some kind of component, you can say VA, okay, VB, and VC, and so on, right? You can say VM, whatever you want to take, okay. So you have been given two vectors, okay, and you're going to find the norms of these two vectors, okay. How you're going to find the norms? You will take the difference of these two vectors, okay. So in order to find the difference, why we are finding the difference of two vectors? If we have been given two vectors, right, definitely we will try to match the present photo with the old Aadhaar card photo, right? So there should not be mismatch, otherwise that Aadhaar card will not be allowed, understand? Okay, so we need to update them, okay. So the norms of a vector, if you're going to find the norms of two vectors, okay, like after taking the difference, the norms of a vector is going to describe how close the two vectors are, okay. How close, this is very important line, how close the two vectors are. Understood? How close the two vectors are. If two vectors are given, two photos are given, so we need to find the match, okay. And there should not be any deviation, there should not be any error, okay. If there is an error, keep in mind, suppose one picture and another picture is not getting matched, it means there is an error, okay. In order to find then you need to minimize the error as well, okay. Then you need to minimize the error. This is also very important concept, right? So suppose given a vector v1, okay, some vector is given, right, some vector is given, you can say some vector, okay, v1 v2 v3, and there is a v2, okay. So it has also been given some vector va, vb and vc, okay. So if you're going to take the difference between the two, right, so there will be some error, you can say v1 minus v2, okay. So there will be some error, right. So you can say that one vector v1, okay, one vector v1 is alpha times, you can say v1 is alpha times v2, okay. V1 is alpha times v2. So if you're going to take the difference, so new vector you will get, so it will be v1 minus alpha times v2, right. So this new vector which you are getting is the error vector, error, okay, because we have to minimize this error, right. The present picture and the old picture should match, okay. So we are trying to find the closeness between two pictures or closeness between two vectors. So this error has to be minimized. So how to minimize this error? To minimize, okay, this error to minimize. How to minimize the error? Everybody knows that by differentiating, right? So if you want to find the alpha here, so you can minimize this error because your v1 is alpha times v2, so you can differentiate this, okay, dv by d alpha and equal to 0, right. So you will get the value of alpha as well, okay. At that value the error will be minimized, okay. This is one of the very important concepts. So as I told you that norms, okay, norms of vector is nothing but the length of the vector. So suppose we have got xy plane here, y and x plane, right, and any point is there on the plane, you can say this is a point v, okay, and this is origin here, and this point has a coordinate, you can say 3 and 4. If somebody is asking that what is the length of this vector, so you can say that the length of the vector is going to be what, under root 9 plus 16, that is 5, okay. Length of the vector, the position vector, you can say from origin to this point, this length is going to be 5, understood. So this vector basically we represent norms with these kind of a notation. So norms of a vector is written like this, which is equal to under root 3 square plus 4 square, which is under root 25, and this is 5. The norms of a vector is nothing but, so up to 2d, 2d we call it length of a vector, but after 2d like 3d, 4d, 5d n dimensional vector you will get, so we start calling norms of a vector. So there are different types of norms, okay, L2 norms, P norms, but in this session I'm just going to discuss about norms of a vector, right, primarily. In later sessions I will also discuss about what is the meaning of, what are the types of norms of a vector, right. In fact, I will also tell you the norms of a matrices, because till now in the exam IIT or ISC did not ask about norms of a matrices, okay, but next year they might ask, so I will be covering that also. Okay? So any point is there, so this point can be written in the form of like this component wise, okay. After these are the components, so 3 4, if you want to find the, if you have been given a vector 3 4 like this, okay, so you can find the norms of a vector. I believe this is fine. And if you have been given two vectors, right, this kind of vector, okay, understood. So suppose this vector is v1, this vector is v2, so you need to find the difference between these two vectors, right? You can say this is v1 minus v2, okay, v1 minus v2 is the difference, right? So you can find the change in the vector. Change in the vector will be what? v1 minus v2. Change in the vector means find the length of the vector, okay. And which is the change in vector means what? That is the length, or you can say change in length, okay, or you can say the error, okay. This is basically the error, okay, because we are trying to find how close our two pictures are, right? So I hope this makes sense. So because in future you will go for machine learning, so you have to analyze the data, okay, and you have to match it. So you might have seen nowadays AI generated pictures, okay, they are crystal clear, they are amazing, okay. So old pictures are being, AI generated, and you are getting very crystal clear pictures, right? Because the old pictures are being matched with the original one, okay, and they are trying to minimize their by different means, okay. So in the gate examination also this year question was there, okay, that you have to make sure. So this is the meaning here, the two vectors are how close they are, right? So we try to find the difference and we try to get the length of that vector, and then we can minimize that, okay. So suppose we have been given example, let me take here. So this time I'm gonna take many components of any vector. Suppose any vector is there 1 2 3 4, okay, and we want to find the norms of vectors. So what is the norms of a vector? Norms of x, you can say, you can write like this, will be equal to under root the component is square, like 1 square plus 2 square plus 3 square plus 4 square. Okay, this is the norms of a vector, okay. You can also take the transpose of the vector. What is the meaning of transpose? That you have to understand, because till now I did not cover the basics like transpose, trace. I believe everybody might be familiar. I will be discussing them also. Transpose of a vector, or you can say transpose of a matrix, is what? Interchanging rows and column. That's it. Interchanging rows and column. Okay. So here x tau. Sometimes in the exam they might ask like this also. X transpose is given like 1 2 3 4. So you guys can find the length of a vector, which is going to be what? Which is going to be what? So x transpose is given, suppose, okay. So you have to find what? You have to find the length of the vector, right? So how to find the length of the vector? Tell me. What you can do here is that you can take x dot x transpose, okay, x dot x transpose, and take the square root, okay. So you will get the length of the norms, okay. So this is also one of the very important condition, right? So length of the norm, okay, or norms of a vector, sorry, not length, norms of a vector, okay, can be written like this also, square root of x dot x transpose, okay. So we can take that similar example, right? Suppose we have been given vector x, okay, that is x1 x2 x3, okay, and we have to find the norms of vectors. What we can do, you can take x transpose as well. X transpose is going to be what? X transpose is nothing but x1 x2 x3 like this, okay. Now you can take the dot product. So x dot x transpose is going to be x vector, you write here x1 x2 x3, and x transpose you write here x1 x2 x3. Now you can multiply. So upon multiplication, what will happen? It will give you x1 square plus x2 square plus x3. Okay, I believe this is fine. Yes, and then you can take the square root of this. So you need to find the square root of this also. The square root of x dot x transpose will be equal to norms. So this, based on this relation, one question was there in the gate examination. So that question you have to solve it. Okay. I hope what is the meaning of norms everybody understood. What is the meaning of norms? Norm is nothing but what? Length of the vector. Norm is nothing but length of a vector. Okay, this is very important concept, guys. Length of a vector, or if you want to find the closeness between two vectors. Okay, closeness between two vectors, we use the concept of norms. And if there is a difference, if there is an error between two vectors, so you can minimize that error, right? So this year one question was there in the gate examination. That question I'm going to mention here, right? So just note down that question. The question in gate 2023 in ECE branch. So many students were not able to solve this kind of question. So you should be able to solve, right? So what was the question? So we have been given, let one vector was given v1. V1 was 1 2 0, right? And v2 was 2 1 3. See, in this way nobody teaches okay, everybody teaches what? Okay, this is how we find the length of the vector. That's it. What is the use? If you understand the real application of these concepts, right, you will never forget. Okay, you will never forget in your entire life. And if you're going to appear in the gate examination, so you will be able to get it through, right? Otherwise you will not be able to solve and in the exam pressure. Why? Because you haven't been exposed to this kind of a concept. Okay, if you're wasting your time only solving determinant problems, multiplying two matrices, okay, uh, adding two matrices, finding adjoint of the matrix, finding cofactor of the matrix, okay, finding determinant using some shortcuts is not going to help you understand entire linear algebra. Linear algebra is what basically is the central problem of solving system of linear equation, right? So you need to understand the heart of linear algebra, that is the vector concept. Okay, the vector space. After these couple of sessions, I will come back to vector space, and one session I will give you on basics. Okay, where you can learn how to multiply two vectors. Okay, sorry, how to multiply two matrices, because everybody knows that how to multiply two vectors. We can take the dot product. Okay, yeah, so v1 was this and v2 was that. Okay, be the two vectors, be the two vectors. Okay, the value of the coefficient alpha in the expression, right? So the value, they are asking the value of the alpha, right? Value of the alpha, coefficient alpha in the expression, okay. So this was coefficient alpha in the expression. What expression they have mentioned here is v1 equal to alpha times v2 plus error. So which minimizes the length of the error e is, right? You have to find the alpha value so that the length of the error can be minimized. Okay, that you have to keep in mind. This is very important concept, right? So this year in the gate examination, this was asked from my lecture only, right? So you can understand, right? So whatever I teach in the classroom, so you can see here, I try to explain you. I try to explain what I try to explain, basically the basic concept, the real life examples, right? So you have to understand. So okay, so next question is what? Which minimizes, okay, which minimizes the length of the error vectors. length of the error vectors. Okay, so this is your question, and there were some options as well. Your option A was alpha value is 7 by 2, option B is minus 2 by 7. Nobody was able to solve this question. I mean, I'm not talking about toppers, I'm talking about the average student, right? They don't understand these things. 2 by 7 and D equal to minus 7 by 2. They think that, oh, this topic is not taught. Actually, in most of the places, you will find that people are teaching matrices and determinant only in entire linear algebra. So we always lose, the basics, the basic concept behind linear algebra. Why linear algebra is mostly used in today's generation to analyze any data, right? So v1 is given, v2 is given, these are the two vectors, and we have to find the alpha in the expression. This alpha is present here, v1 equal to alpha times v2 plus e, which minimizes the length of the error vectors. This is the error vector e, right? We can take the, we can start solving this. It is very simple, as I told you, how to minimize the length of the error. Okay, so first of all, we need to understand how to find the error. So we have been given an expression v1 equal to alpha times v2 plus e. So you can find e directly. So it is v1 minus alpha v2. Okay, now you can put the value here. Right? So you can put the value, whatever values are given. So v1 is given as, let me check here, 1 to 0, right? So you can put here 1 to 0 minus alpha times v2. Your v1 and v2 are having alpha difference, that's it. One is alpha times, okay, so 213, this is 213. Okay, now you can find the error here. So error will be equal to basically 1 minus component of the error, right? Just we are trying to find the component of the error. Why? Because we have to find the length of the error, then we have to minimize it, okay, to determine the alpha. Okay, to determine the alpha. I hope this makes sense. So these are the steps. Okay, so let me read the question again. The question says here is that let v1 and v2 be the two vectors, the value of alpha in the expression. Okay, this coefficient alpha we have to find out. So this was the expression v1 equal to alpha times v2 plus e, which minimizes the length of the error vectors. Okay, which minimizes the length of the error vectors. So these are the options. Now, so what we have to find out is we have to find the alpha. So first of all, we can find the error. Error is nothing but v1 minus alpha times v2, and we can find the component. So 1 minus 2 alpha, this is 2 minus alpha, and this will be 0 minus 3 alpha, I can say. Yeah. 1 minus 2 alpha, 2 minus alpha, minus 3 alpha, right? So we have been given an error vector, and it has 3 components basically, right? How many components are there? It has 3 components. You can see 1 component, 2 component, 3 component, right? Now we can find the length of the error. How to find length of the error, guys? How to find length of the error? That you must know. Okay. The length of the error. Length of the error vectors. Length of the error vectors we can find out like this. You need not to find the E transpose and then multiply. Directly you can take the square root of squares of the component. Okay, square root of squares of this component. The first component is 1 minus 2 alpha square plus 2 minus alpha square, and this minus sign vanishes, if you take the square. Okay, so now we can find this. So you can also take the square of in order to remove this square root. Okay, you can take the square of the length, right? So it is going to be 1 minus 2 alpha square plus 2 minus alpha square plus 3 alpha. Now you can further solve this, right? If you can further solve this, and then you can minimize, okay, in order to find the value of alpha, that coefficient. The actual problem is to determine the value of coefficient by minimizing the length of the vector, right? So you can do like this. You can open this guy. So 1 plus 4 alpha square, and this will be minus 4 alpha plus 4 minus alpha square, and this will be minus 4 alpha, and then this was square only, so it is 9 alpha square. So you can further solve this, right? So then once you simplify this expression, so you can differentiate with respect to alpha and equate to 0, okay, to in order to determine the value of the alpha, right? I hope if you understood the concept, you can solve the question. Okay, if you did not understand the concept, it takes time to digest, okay, and solve it. So here we are solving confidently. So you can see here so what is given here, first of all, you see you can further resolve this, right? So it will be 14 alpha square, 14 alpha square minus 8 alpha plus 5. If you solve this, you will get 14. You see 4 plus 1 5 and 9, that is 14 alpha square minus 8 alpha plus 5. Now what you can do to minimize this, to minimize length of the error, okay, what we can do here is we can differentiate this with respect to alpha and equal to 0. That's it. That is what you have to do. So if you're going to differentiate this guy, so it will be giving you 28 alpha minus 8 equal to 0, right? So it will be 28 alpha minus 8, sorry, because you can see here this constant differentiation of this constant will be 0. So 14 into 2, that is 28 alpha. After finding this, it will be coming out to be 14 alpha minus 8, sorry, 14 into 2, sorry, this should be 28 alpha minus 8. So now you can equate to 0. From here you will get 8 by 28, right? What is 8 by 28? That is alpha equal to 2 by 7. So this is the answer. If you do not understand the application, if you do not understand, if you are not you are just mugging up the formula that norm is just a length of the vector, that's it. So you might get surprised, oh, this is a new question, right? But these are the applications of derivative we are using here, for minimizing or maximizing the error. Okay, so this was all about the gate 2023 problem. Okay, so I hope this makes sense to understand, right? So I have also explained you, suppose we have got, this is the pixel, collection of pixel in terms of vector 1, and second collection of pixel in terms of vector 2 of the new image, you can see. Now we are trying to find the error between the two, then we are determining the length of the error, then differentiating and finding out to this. So next concept is after norms, right? That you have to keep in mind. After norms, we talk about normalizing the vector. Okay, if you want to normalize the vector, normalizing the vector. So how to normalize the vector, right? That you have to understand. So if you want to normalize the vector, just take the vector and divide by norms of vector, right? Okay. So what you will get here is that you will get new vector v, length of the vector v, and you will get 1. Okay, I hope this makes sense to everyone. So normalizing the vector is nothing but just by dividing the norms of vector. Okay. Now the question is how to find dot product of two vectors. Now we'll understand the concept of dot product of two vectors. Okay. Because after this concept, after understanding the dot product of two vectors, we will be able to understand the orthogonality of the two vectors. How you can say that two vectors are orthogonal to each other, right? That you have to understand. Okay. So dot product of two vectors, that you have to keep in mind. So suppose we have been dot product of a two column vector. I'm talking about two column vector, right? Two column vector. That you have to understand. Two column vectors. Okay. So suppose we have been given two vectors. X vector is this. X x1, no, x2 dot dot xn, and we have been given a vector by, which is by 1 by 2 and so on by n, right? So if we want to find the x dot by, that is the dot product of two vectors. Okay, so keep in mind always that dot product can be found out like this. Okay, because you can't directly multiply these two column vectors. Okay, because it has the dimension, n cross n, it has the n cross. Okay, the size of these two matrices are this, and when you can multiply two vectors, when you can multiply two matrices, when the column of the first matrix should match with the row of the second matrix. That number of column in the first matrix, okay, when we can multiply two matrices, that is very important condition. Two matrices. So when we can multiply two matrices, right? So remember that suppose we have got matrix M cross N, and there is a matrix M cross N. These are the two matrices of different sizes. If N is not equal to M, remember, if N does not equal to M, therefore they are not conformable. Okay, they are not conformable. Okay, what is the meaning of conformable? Conformable means the number of column. Okay, what is the meaning of conformable? Conformability. Okay, conformability means number of column in a matrix should match to number of rows in B matrix. Okay, if they are not matching, it means they are not conformable. That you have to keep in mind. Okay, you can't multiply if they are not conformable. We can't multiply. That you have to make sure. Okay, if these two matrices, given matrices, are not conformable, this is very important concept, right? If conformability is not holding, then you cannot multiply. That you have to keep in mind. So coming to here, you see here n cross n and n cross n. Here you see number of column in the matrix 1 is 1 and number of rows in the matrix is n. They are not equal, right? You can't multiply. That you have to keep in mind. So whenever you want to find the dot product of two vectors, okay, two different vectors I'm talking. Okay, dot product of two different vectors, two different column vectors, you can say, or different. Okay, so what you can do, just multiply component wise. Okay, multiply component. Okay, component wise. Okay, multiply the components. Okay, with each other, you can say multiplication. Okay, perform the multiplication. Okay, component wise, that you have to keep in mind. So what is the so let me take this guy in the next page and explain. Okay, dot product of two vectors are very, very important. Okay. So basically in terms of matrices. Okay. So you see here, so what we can do here, component x1 and y1. So just multiply x1 by 1 plus x2 by 2 plus and so on xn by n. Simple. The dot product of two column vector is very simple. What we will do, we'll directly perform the multiplication component wise. Okay, understood? Dot product directly, if you want to find that okay, dot product between two column vectors. So what you can do, perform multiplication, okay, component wise. Okay, or what you can do, suppose you want to find the dot product with the same vector, right? Suppose you want to find the dot, suppose we have been given like this, x vector is given, that is x1 x2 x3, and if you want to find the dot product with itself, right? So you can say that we want to find x dot x. What is the meaning of x dot x? You can't directly multiply these two vectors. What you can do, it will be equal to x dot x transpose, or x transpose equal to x. So this is very, very important to do. Okay, understood? Suppose we have been given x vector 1 2 3. Now we want to find the dot product with itself. You can say x dot x. How to find x dot x? Just take the vector x and take the transpose of that, or you can take the transpose of that and you can multiply it with that. Right? That is what the concept is. Okay, so we can find quickly x transpose. So it will be 1 2 3. Okay, I hope this makes sense. So we can take x dot x we want to find. Okay, or what you can do, you can component wise also you can do, right? Multiplication. So it is 1 2 3, and this is 1 2 3. I'm just writing here because this is x transpose and this is x. So it will be it's going to be 1 plus 4 plus 9. Okay, so this is going to be what, x dot x. Okay, dot product, and dot product always produces scalar, right? The number, or x transpose 1 2 3 multiply by 1 2 3. So you will get, you can write this as 1 2 3 transpose 1 2 3. So just multiply this, one time multiplication. Okay, so what is this? This is 1 3 3 cross, okay, sorry, one row is there, no, 1 by 3, and this is 3 by 1. Okay, so if you take the final, so you will get 1 by 1, simple. Okay, so 1 by 1 will be what, 1 plus, okay, so it will be 1 plus 4 plus 9. You see here, if you are going to take the dot product with itself, the vector itself, right, the given vector itself, dot product with the vector itself, so you can write this as x transpose x, or x transpose. I hope this makes sense to everybody. Okay, you guys can watch these sessions any number of times. So as we were trying to find the x dot by the dot product of two vectors, what we have to do here is, remember, x, either you take x transpose by x by transpose, or you can say, you can write x transpose by. So this definition is very important in terms of transpose of the matrix. So what we are doing here is, we are changing, we know how to take the dot product of two vectors, right? But in terms of matrices, in terms of we have to use some of the concept of linear algebra, right? Like trace of the matrix, or you can say the transpose of the matrix. Okay, the property here we are using is transpose of the matrix, not the trace, right? X dot by equal to x dot by transpose. Okay, T means transpose, and then multiplying. Okay, so I hope this makes sense. So remember, dot product of two vectors is what, x dot by equal to two different vectors, x transpose by or x by transpose, both are same, and x dot x, suppose you want to find, so it is x transpose x or x transpose. Suppose you want to find by dot by, so you can write this as by transpose by, or by transpose. So these are the generalized understanding. Okay, you don't have to mug up. Why we are taking transpose of the matrix, okay, because so that we can make it conformable, okay, conformable, and you can multiply then. Otherwise you can't multiply two matrices, okay, they are not conformable, right? So this note is very important. We cannot multiply two matrices if they are not conformable. If they are not conformable, don't try to multiply two matrices, okay? There is a story. During my college days, we used to give non-conformable, like, I mean, the matrices which are not conformable. So still many of my colleagues, they start directly, multiplying it until you confirm whether the matrix is, given two vectors are conformable, you can't, okay? So remember this, okay? So this is very important concept. So dot product of two vectors is this, or dot product with itself, okay? Now we'll talk about the concept of orthogonality. So whatever concept we have used, we have talked, in fact not used, we have talked, right, since beginning of the session, right? We discussed about, we started with norms of a vector, right? Then we landed up talking about the how to find dot product of two vectors, right? So now combining the two concepts, we are going to talk about the concept of orthogonality. Concept of orthogonality. Okay, so what is the meaning of orthogonal? Everybody knows that. What is the meaning of orthogonal? See, whenever you hear the word orthogonal, okay, it means perpendicular. Okay, so orthogonal is nothing but what? Perpendicular. Okay, orthogonal means perpendicular. Remember, orthogonal. The word orthogonal means perpendicular. So two vectors are perpendicular to each other, right? You can say. So two vectors x and y are said to be orthogonal. Remember, two vectors x and y. Okay, suppose we have been given a vector, two vectors x and y, and if you say that they are orthogonal to each other, so they should satisfy these following condition, right? So if two vectors are x and y are said to be orthogonal, okay, said to be orthogonal, okay, if and only if and only if, okay, two vectors x and y is said to be orthogonal if and only if, remember, if and only if their dot product is equal to 0. Their dot product is equal to 0. Now you know that what is the meaning of dot product, right? So sometimes they might give you x by transpose equal to 0 or x transpose by equal to 0. Don't get misunderstood, right? This is the very important condition for orthogonality, okay, because we can write dot product x dot by can be written as x by transpose or x transpose by, so in the examination they might give you in terms of transpose and then multiply, any matrix with the transpose of the matrix, okay, and then take the dot product. So you in fact just multiply them, right? Simply, this is just simple multiplication and this is dot product, right? Dot product is nothing but the multiplication of component. You have to perform multiplication component wise, okay? So if I talk about 3D or 2D, right, they should be equal to 0 for orthogonality. Okay. See, there are two different concepts in linear algebra. We sometimes investigate the orthogonality of a vector, or sometimes we also investigate in mid of the chapter orthogonal of the matrix, when you can say the matrix is orthogonal, right? So the similar concept will you use there also, but in this session primarily I'm focusing on norms of a vector, trying to explain you the real picture, okay, of norms. And I'm not talking about types of the norms, Okay, I will discuss 100% because we can't leave any stone unturned, right? We need to I mean, we can't leave any topic, okay, as far as the today's competition is concerned, right? So people who are interested dynamically in machine learning or artificial intelligence, right? So they should be insane about math. So concept of orthogonality, like orthogonal means what? The word orthogonal directly recalls us, okay, kind of perpendicular, okay. So if I talk about two plane like xy plane, two dimensional xy plane, so we can draw like this. So this is y axis and this is x axis. These two vectors like x and y are orthogonal to each other. We call it, right? Angle between any two vector, if it happens to be 90, right? Angle. These are the basic ideas which I'm discussing. So angle between any two vectors, is 90 degree. Okay, this is the meaning of perpendicular or orthogonal, right? So you can take any two like a vector and the v vector. What is the angle here? 90 degree. Okay, or in fact you can also go for Cartesian coordinate system or rectangular domain in 3D, right? So let me take this guy properly. So in fact you will understand everything in vector, but here suppose x, this is y and this is z, so they always follow right hand rule, right? So you see here this is perpendicular to each other, right? If you're going from x to y, right? So they are orthogonal to each other. You can say all angles here, right? The z and y are orthogonal, right? So these guys are orthogonal to each other, right? So this is the meaning of orthogonal. Okay, so this is just a literal meaning, just I'm trying to explain you from your very basic, but we can prove orthogonality, right? Okay, like we have seen that dot product, keep in mind this again, the orthogonal of two vectors, when you can say two vectors are orthogonal, when dot product is going to be 0, or you can say that x transpose y equal to 0, or you can say that x y transpose. These are the conditions, right? So we need to prove them. Okay, so if two vectors are orthogonal, okay, remember, if two vectors are orthogonal to each other, so it means what? If something is two, suppose two legs are there and their angle is 90, so what kind of triangle they are going to form? They are going to form right angle triangle. Okay, so this is the meaning here. If something two vectors are orthogonal to each other, you can also say geometrically we can explore, investigate now the right angle triangle. Right angle triangle. Okay, orthogonal to each other. Okay, so if two vectors are orthogonal to each other means they will form the right angle triangle. This is very basic concept, right? So suppose we have got any vector x, okay, and any vector y, so they are orthogonal means they are 90 degree apart, so we can say that this is going to be x square plus y square. Okay, this is x. You can find the norms of a vector x, you can find the norms of a vector, okay, and then you can also find the norms of a vector here. So just add these two vectors. Okay, so here it will be x plus y norms of vector. So if it is right angle triangle, right, if it is, no, not if, directly you say yeah it is. Okay, if some two vectors are orthogonal means what? They will be forming right angle triangle. Okay, right angle triangle means we can apply the Pythagoras theorem, right? So if this is right angle triangle, so you can apply here now by Pythagoras, okay, because Pythagoras always wait, okay, where you are going to utilize me. So whenever this kind of situation happens, right, so two vectors are orthogonal, say they are forming a right angle triangle, so you can use, you can find the relation between these lengths, right? So individual length, right? So x vector and y vector, you can add these two vectors, right? And you can find the norms of a vector. I think everybody knows that how to find the norms of a vector, right? So just finding the length of a vector, right? Or you can say square root of squares of all the component of a vector. So by whatever I'm speaking, you should be able to write as well. So you can write, apply the Pythagoras. So base square plus y perpendicular square, right, equal to under root, not under root basically. This will be equal to norms x plus y. Okay. So I'm just going to write again. So first of all, suppose x vector is given, y vector is given, right? So you have to find whether they are orthogonal to each other. You can find the norms of x, find the norms of y, okay, and add these two vectors. So I think everybody knows how to add two vectors, right? So you can again find the norms of the two vectors after addition, right? So now you take the square root, the square of this, and add them. So x plus y whole square. Okay, so this is important condition for orthogonality, right? So one definition is not enough, right? You should be able to look at the definition from different angles, right? Different perspective. Okay, so mod square plus, you know, x norms square, okay, square of a length. So this is very important condition. So something is perpendicular or orthogonal means they will 100% allow Pythagoras theorem to be useful, right? And then you can find the relation, right? So I hope this makes sense. Yeah. If something is x norm square, what is the meaning of square of the norm? Square of the norm is not, this is square of the norms. Square of norms of vector x. What is the meaning of this? You know, how to find norms? You know, you can take x dot x, or you can say x transpose. Okay, x dot x or x. So square of the norms, right? So just we have been given. So x square is what? X square nothing but x transpose x, or you can write this as x transpose x, right? Or x transpose, whatever you want to do, right? So we can prove now, right? So just I'm gonna prove it, okay? Like okay, whether this condition is true for testing orthogonality or not. So we have been given, suppose the condition for orthogonality is what? From the Pythagoras, right? So norms square of the norms x, square of the norms y, you can say, or length of the vector x, length of the vector y, taking the square of these them, and also you can find x plus y. Okay, this is also square. Now we can write this as you know, x transpose x plus this can be written as y transpose y. Okay, I hope this makes sense. And this can also be written as you know, x plus y transpose x plus y. Okay, in the similar fashion. So further going forward, x transpose x or y transpose y, you can also write x trans, no problem. And now this transpose will be distributed here, so it will be x transpose plus y transpose times x plus y. Now further you can solve, so it is x dot x transpose x, y transpose y, okay? And this will be x transpose x plus x transpose y plus y transpose x plus y transpose y. Okay, so x transpose x, you see what is being cancelled from both the sides, that you have to see. X transpose x, so this guy and this guy got cancelled, this guy and this guy got cancelled. Okay, so what is remaining here? You see, we have been given x transpose y plus y transpose x equal to 0. Okay, so x transpose y plus x by transpose equal to 0 means what? Both are same, right? Both are same. So you can say this is x transpose by equal to 0, since x transpose by equal to x by transpose, both are same, you know, or you can say x dot by. This is x transpose by equal to 0, or you can say x dot by equal to 0. These are the two conditions. I mean, okay, if you try to find the dot product of two vectors and if it happens to be 0, so you should be able to claim that, yeah, this is the condition for test for orthogonality. Test for orthogonality. Please keep this in mind. So this is very important. So I'm just gonna take one example here, then we'll wind up the session. So example is like x is given 1 2 3. Just I'm gonna prove it whether they are orthogonal to each other or not. Y is given as 2 minus 1 0. 2 minus 1 0. If you're going to take the dot product of directly, right? So method 1 to prove whether they are orthogonal to each other or not, directly find the dot product. So dot product should come out to be 0, right? Then only you can say dot. So x dot by, if you are trying to find dot product of two column vectors, so just multiply component wise. So 1 into 2, it is 2, 2, this is minus 2, and this is 0, so it will coming out to 0, yeah. Or you can also write, if x dot by equal to 0, it means x transpose by equal to 0 or x by transpose equal to 0, both are same. This is the method 1 to verify, yeah, they are orthogonal. But what is the method number 2? That is unique, right? So I'm just gonna take these two vectors from here, just, you know, then we'll try to find it. I mean, using method 2. So something is orthogonal means that they are perpendicular to each other. They will form certainly one kind of a right angle triangle, right? So on right angle triangles, you know, the converse of right angle triangle is the Pythagoras theorem, right? That you have to understand. If somebody is asked what is the converse of Pythagoras theorem, converse of Pythagoras theorem is the right angle triangle, right? Converse of Pythagoras theorem is right angle triangle. Okay, these are very basic things which one must know, right? But you know, during our college days we forget everything. So x dot by, right? 1 2 3, this is. Now what you can do, you can find the norms of this. What is norms? X dot x, x dot x, and take the square. That also makes sense. Okay, so if you're going to find this, so you will get here that just take the square of that. So it will be 1 square plus 2 square 4, and this will give out to 14, and this by square length of square the length, right? It will give you 5. Now you can also find one more vector, that is new vector x plus y. X plus y is nothing but 3 1 3. It is 3 1 3, right? So you can also find x plus y 4 square equal to 9 plus 9, and this will give you 19, right? So now you see, check whether this is being followed or not. What is this? 14 plus 5, that is 19, and this is equal to x plus y square. So they are orthogonal. Okay, these guys, given guys, are orthogonal to each other, right? So this is the concept which I wanted to talk today in this session, and remaining concept we will discuss in the next session, right? So for this session, okay, for this session, this is enough. And if you like the session, please do comment, right? Okay. If any vector is a zero vector, so that will be always orthogonal to each other. That concept also you have to keep in mind. So if you really if you're really enjoying these sessions, do let me know also, so that I will try to improvise some of the more concept. I will try to add here, right, which might be asked in the game. Thank you so much, guys. Please do watch these sessions. They are readily available. They are in the recorded form. You guys can watch and comment and write your feedback. Okay, thank you so much.